welcome to True Projects. In this video, we are going to explain about the project that is improving sleep disorder diagnosis through optimized machine learning approaches. So before getting into the execution, let us understand what is the project about. So now some people they may be sleeping for 8 hours, but they still feel tired and also drowsy throughout the day. This may be caused by a sleep disorder such as insomnia or sleep apnea, which disrupts the normal sleep cycle. Sleep is essential for both the physical and mental health. It helps the body to repair itself, support brain function, and also maintain overall well being. Disturbances in sleep can lead to serious health problems, including heart disease, diabetes, and obesity, which affects person's quality of life. And here, understanding the different stages of sleep, that is wakefulness, light sleep, that is N1 and N2, deep sleep, that is N3, and REM, is crucial for assessing sleep quality. Traditionally, these stages are analyzed using polysomnography (PSG), which requires expert evaluation. However, this manual process is time consuming, labor intensive, and prone to errors, which makes it difficult to diagnose sleep disorders accurately and promptly. And diagnosing sleep disorders accurately is challenging because it often depends on experts manually examining sleep data. This process can be inconsistent as different specialists may interpret the same information differently, and it is also time consuming and inefficient. The complexity of sleep patterns adds to the difficulty, making it hard to analyze large data sets using conventional methods. And when sleep disorders are misclassified or diagnosed late, it can negatively affect patients' health and also overall well being. This highlights the urgent need for more reliable and efficient approaches that can quickly and accurately detect conditions such as sleep apnea, insomnia, ensuring timely intervention and better healthcare outcomes. So this is the problem that we have. And now to overcome with all these issues, here the proposed system is designed to accurately identify different types of sleep disorders, such as sleep apnea, insomnia, etc., using the real world data set. So it works by combining several steps into a single intelligent framework. So here, first the dataset is clean and prepared through pre-processing, which includes handling data imbalance, that is class imbalance using this SMOTIN technique. And then the categorical information is converted into numerical form using this label encoding technique. And also we have used Z-score for normalizing the data. That is to standardize the features so that no single variable dominates the analysis. Next, the system enhances by feature engineering. So here we will be using this ANOVA technique for feature engineering, that is to select the important features. And the system enhances the dataset through feature engineering augmentation. It generates new features based on predicting the that is predictions from multiple machine learning models. So here we will be using multiple machine learning models to generate the new features. And the system uses variety of machine learning algorithms to classify sleep disorders, including both individual models and ensemble models. So here the individual models are decision tree, random forest, gradient boosting, XGBoost, light GBM, CAT boost, support vector machine, logistic regression, and ensemble models such as voting and stacking classifier. And here we have used gradient boosting regressor for selecting the important features. This process identifies the most important features, reducing unnecessary complexity while enhancing the performance. And by integrating thorough pre-processing, engineered features, and these advanced machine learning models, the system achieves high accuracy, precision, recall, all while maintaining, that is, remaining computationally efficient. So here we will be using these evaluation metrics to evaluate this project. And moving on, as an extension, the system incorporates explainable AI models, that is XAI models, such as LIME and SHAP to make the model predictions more transparent. These tools help users to understand how each feature contributes to a particular prediction, increasing trust and also reliability, that is interpretability of the system. And also we have used Flask-based frontend, which is developed to allow users to interact with the system easily. Through this interface, users can input their data and view application in a user-friendly way. To maintain privacy and security, user authentication mechanism has been added, which ensures that only authorized users can access the system while enabling practical testing of its functionality. So this is proposed an extension part of the project. Now moving on to the implementation. To implement this project, we have followed these certain steps. Now let's understand them. First, we have loaded necessary Python libraries for data processing, visualization, and machine learning. Then comes exploratory dataset part. That is the second step. In the second step, we load and examine the sleep, health, and lifestyle dataset, check its data types, missing values, and overall structure. In the third step, we visualize target values, that is target values to understand class distribution and generate a correlation matrix to examine relationships between features. And we also visualize categorical columns to understand category distributions. Then we used ANOVA for selecting the important features. So here we applied ANOVA test to identify statistically significant features for the classification purpose. Then comes feature engineering part, where we have created new features using predictions from machine learning models. 7 new features have been created here. And they are engineered from random forest, gradient boosting, Gaussian naive Bayes, KNN, decision tree, logistic regression, and support vector machine to enhance the pattern capture in the data. So this is how we have done feature engineering. And for resampling, that is to address the class imbalance, we have used smoothing technique. This creates a more balanced training data set. And in the next step, we store input features in the X variable and output features, that is a sleep disorder, in the Y variable. Then comes train and test split part. So here we will be splitting the data into training and testing sets. Training set is of 80% and testing set is of 20%. Then comes building the model part. So here in this step, we train ML models using 5 selected features and 2 key features. Then comes visualizing the confusion matrix. So here we visualize confusion matrices for all the models to evaluate classification performance. Then comes model evaluation. So here in the step, we compare the models using accuracy, precision, recall, FN score, sensitivity, and specificity. And in the next step, here we create visual graphs to compare the performance scores of all the models. And then we will be saving the best performing model. And here we have used Lyman-Sharp techniques to interpret and also explain the model predictions, highlighting contributions of the individual features. And this is for execution. And for front-end part, so here for front-end, we have used Flask-based framework for the development of the front-end with the registration and login functionality supported by SQLite database. And in the front-end, users, they will be able to give the feature values that will be pre-processed at the backend, and it will be fed to the train model. Finally, train model will be predicting the outcome whether the person has insomnia, sleeping disorder, that is sleep apnea, or he doesn't have any disease. So this is how we need to implement. And these are the algorithms used in this project to detect whether the person has sleep apnea or not. And these are the requirements. To implement this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, let's open the code folder of the project. So these are the source code files which are important for this project. So here in this folder, we have the data set. Let's open it. This is the data set we have used in this project, that is sleep, health, and lifestyle data set. So these are the different features based on which we will be predicting sleep apnea. So these are the independent features which impact whether the person has sleeping disorder, that is sleep apnea, insomnia, or he doesn't have any disorder. We will be training machine learning models on all these independent features. Based on these features only, the disorder will be predicted. Now close this and get back. And here in the model folder, we have the algorithm information that will be loaded into the project code during runtime of the application. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here in this folder, we have this is the templates folder. In this folder, we have HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the test cases folder in which we have test cases. So here we have 2 and 5. So in this file, that is sample ENG file, here we have 5 features. That is 5 newly created features from machine learning models. And here only 2 newly created features. Let's get back. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have the notebook files. So here we have multiple notebook files. So in this notebook files, we will be having code. That is the Jupyter Notebook code. Here, this notebook file is a Jupyter Notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So here, in these two files, we have original features on which ANOVA technique has been applied for feature selection, and then we have trained the models. And here in these two notebook files, we have used machine learning models to create new features. So here we will be using some machine learning models to create new features, and that new features we will be giving as input in the front-end prediction. And these are the HTML files of these notebook files. And these are the PDF files. And this is the signup.db file. This is the database file which is used to store the user information. So this is all about the code folder. Now let's execute. So to execute, copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open Anaconda prompt. So here Anaconda prompt is open. Now give the command cd, give the space, paste the copied path. Now click on enter. Here you can observe current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py. Now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port. So this is the localhost and this is the port. This 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is developed using Flask framework. Now we need to sign up. So click on sign up and enter all the registration details if you are creating your account newly. I have already created my account, so I will directly sign in. Click on sign in. Give the username and the password. So I'm giving my username and the password. Click on sign in. So we have signed in successfully and we are redirected to prediction page of the project. And now we will be doing prediction based on 5 features and 2 features. So click on 5 features. Here we are supposed to give the features that are created by the machine learning models. So let's open the test cases file. Let's open the 5.1. Let's apply filter to this column. That is the prediction column. Output column. So here we have 3 different classes, 0, 1, and 2. Let's apply filter to 0. Click on OK. And now here, if you observe, these are the inputs. So the first created feature is 0, and the next one is also 0. That is created feature 1, created feature 5, and created feature 2 is also 0. And the sleep duration is 6.4 hours, and the age is 44. Now click on predict sleep disorder. Click on that. So here you can observe that we got the prediction. So the person has insomnia. You can observe person has insomnia, sleeping disorder. So this is about insomnia. It is a it is a common sleep disorder that can make it hard to fall asleep, hard to stay asleep, or cause you to wake up too early and not to be able to get back to the sleep. So this person has insomnia disorder. Now let's check with the class 1. Let's check with this one. Click on check again. So here created feature 1 is 1, 5 is also 1, and 2 is also 1. And sleeping duration is 6 hours, age is 33. Now click on predict sleep disorder. So here the person has no disorder. He is completely healthy. He has no other disorder. Now let's check with some more. That is with the class 2. Let's check with this case. So here created feature 1 is 2, 5 is also 2, and 2 is also 2. Sleeping hours are 8.2 hours and the age is 59. Now click on predict sleep disorder. So here if you observe, we got the prediction that person has sleep apnea. So sleep apnea is potentially serious sleep disorder, which causes breathing repeatedly stops and also starts. If you snore loudly and feel tired even after a full night's sleep, you might have sleep apnea. So this is with the 5 features, and now let's check with the 2 features. So now let's open this file. Here, let's check with this one, where created feature is also 1 and 5 is also 1. Click on predict sleep disorder. Here, person has no sleep disorder. Let's check with the other cases. Let's check with this one, where both of the features are 0. So here we got the prediction that it is insomnia. Person has insomnia. Now let's check with the class 2. So here we have created feature as 2 and also that is created feature 1 as 2 and 5 also 2. Now click on predict sleep disorder. Here we got the prediction that person has sleep apnea. So this is how you need to do the prediction. Now let's check with the graphs. So click on about. Let's see the graphs of 5 features. Click on that. So here we have the sample outcome graph, which shows the class distribution of the target that we are predicting. Click on plus. So here on x-axis, we have the targets, the outcome that we are predicting. And on y-axis, we have count of each class. And this is the sample outcome in the pie chart. So here 58% of the people are with the no sleep disorder and 20% with the sleep apnea and 20% with the insomnia disorder. Here we have heat map, which shows the distribution, which shows the correlation between individual features. And this is the confusion matrix. So this is the confusion matrix. And here we have accuracy comparison graph. So this is the accuracy comparison graph. Here on x-axis, we have all the algorithms that are trained, and on y-axis, we have accuracy score of each algorithm. So this accuracy is the overall accuracy of the models on the dataset. And here we have precision score, recall, FN score, specificity, and these are the evaluation matrix graphs. And here, this is the explainable graph, that is SHAP graph. Let's close this, which shows the feature importance. Similarly, we will be having for the 2 features also. Here you can observe, right? So these are the graphs for 2 features. Now click on sign out. In this page, just by giving input to the application, that is the features to the application will be predicting whether the person has sleep apnea or not, or whether he has sleep apnea, insomnia, or whether he doesn't have any sleep disorder. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.